Okay, here we're going to solve a linear system using the substitution method. The linear system here is these two equations aligned, 4x plus 2y equals 34, and x equals negative 3y minus 4. Okay, so it's a very mechanical process given by these steps. Before I read them, just put a little focus here on what I refer to as step 0. Step 0 may seem odd, but if you get used to my teaching and my videos, step 0 is usually referring to something that not every problem requires, but you should look for it in every problem because some of them do. Kind of like a prerequisite sort of condition maybe that needs to be met. And in this case, we see that step 0 says that we would have to isolate one of the variables in one of the equations. That helps us proceed more effortlessly in doing the substitution method. And the steps that follow are: 1. Substitute the isolated variable's equivalent expression into the other equation. Solve for the remaining variable. Plug that value into one of the original equations. Solve for the other variable. Write the solution as an ordered pair. Okay, so up here, starting at step 0, which this problem will not require, you'll see quickly, it says isolate one of the variables in one of the equations. Well, see here that in the bottom equation, x is by itself. That's what it means to be isolated. So this is kind of an easier example because you don't have to do this prerequisite step. So it says substitute the isolated variable's equivalent expression into the other equation. Kind of a mouthful, but pretty simple. So here we have the equivalent expression to the isolated variable. The isolated variable is x. The equivalent expression is negative 3y minus 4. Now, the fact that they are equal means they are interchangeable, which means where I use one, I could use the other. So that means that in the other equation where I see x, I actually could substitute the expression negative 3y minus 4. And I will, and my writing will reflect that. So I'm going to do 4 times the quantity of negative 3y minus 4 plus 2y. Excuse me, just a little color change there. Plus 2y equals 34. And again, we see that this is sort of 4x plus 2y equals 34, which is the original equation, just again with the proper substitution. So that takes me to step 2, which is solve for the remaining variable. Well, that's where I'm going to use my sense of DCG01, which maybe you've seen in previous videos or in class, which means distribute, collect, get all my letters on one side, undo, add, subtract to make a 0, undo, multiply, divide to make a 1. Okay, so let's get to work on that. So I'm going to distribute and get negative 12y minus 16 plus 2y equals 34. Then I'm going to collect my like terms, which I only have negative 12y and 2y, which gives me negative 10y. Bring down the minus 16 equals 34. So check that I've done distribute and collect. Then G for get all your variables on the one side. You don't have to do that because they are. Undo, add, and subtract. Well, this says minus 16, so I'll do plus 16 on both sides because that's the golden rule. And that's going to give me negative 10y equals 50. Okay, and then I'm going to undo multiplies and divides, which is the next step there, which means to make a 1. Okay, because the multiply that undoes the divide, I'll turn that into 1y, and that will give me y equals negative 5. So I'm halfway there because I've got to find both values here. So plug that value into one of the original equations, it says here in step 3. Well, it doesn't matter which one I use. So I'm going to take this y value from one of the original equations. Well, I'm going to take the bottom one. I'm going to take the bottom one because if you notice, the x is by itself already, and that's what I want to find. So I'm going to take the bottom equation and substitute in that value for y. So I'll start writing x equals negative 3 times y, which in this case is negative 5. Continuing to write that equation, minus 4. Then it says to solve for the other variable. Well, solving here won't require DCGO1 because I have the letter by itself already, so I just got to simplify this expression. So I'll do that using PEMDAS. So I'll multiply first and get 15, bring down my minus 4, continue to simplify to get 11, which then is how I in fact solve for the other variable. Lastly, it says to write the solution as an ordered pair. That just means to write x comma y, so I'm going to write 11 comma negative 5. Graphically, this is where these two lines intersect, okay? And furthermore, what it means is if I took the x values and y values and put them in both equations, I would get two true statements. That's what it means to solve, which you should understand by the time you've gotten to this method. Okay, so enjoy, and I hope that's helpful.